Be quiet.
Okay.
They can hear you.
Number 4C.
Yeah.
When you scale, be quiet. They'll say, okay.
Is a true proportion.
All right, let's see.
Is it true?
Include the normally distributed as NP.
Is P the true proportion or the sample?
True.
I remember reading in the.
It's the true proportion. Yeah. B, true proportion.
P is true proportion?
Yeah.
Yes.
Yeah.
Is the P hat the sample then?
Yes.
P hat is a yeah.
Is a sample
P hat
proportion.
is the sample proportion.
P hat, here's what the text says. P is the true theoretical mean for the random variable P hat. So P hat is a random variable. P is the true theoretical mean.
So that would be the true
Of
proportion.
everybody.
Yeah. Yeah.
Okay.
So it's the population portion.
It'd be the true portion.
What is N?
N is the sample size.
Yeah.
That's always been. And
And he won't put that. Every time I take it down, to go back on, he puts it back up. Okay. We'll try that if he doesn't be quiet, we'll be the first one by tomorrow.
If P is 1/4, what's the smallest number that satisfies the requirement?
wouldn't that be 4?
4, because you get 1 out of 4, 25%, so it's 4.
Yeah, that's what I was thinking.
What's your thinking there?
For question 7?
How did you get to 4 though?
Well, if P is 1/4 of the, if it's 1/4, wouldn't you have 4 for the
Well,
population?
the two requirements are n times P is greater than or equal to 10, and then the other
that's
one.
right.
So
it would be 12 then, wouldn't it?
So I think, don't we have to insert a quarter into that equation?
Or 16?
No, that's just the NP is greater than or equal to 10 is just telling if the group's large enough to have a normal distribution.
So number 7 is 4.
What's the requirement they're talking about in 7?
Be quiet, people.
Doesn't make sense.
I don't think there's a requirement. I think it's just saying what's the smallest number that would satisfy 1/4.
Yeah, because it's not asking whether it's normally distributed. It's just
But we have a similar example on the handwork. Number 6, and we have 1/10, and the answer is 100. But do you have the handwork paper?
Say that again, Jose.
Okay. If
your volume's low.
If you can see the handwork paper for this lesson, look at question number 6. We have a similar exercise, but this time is 1/10. If you see the answer, the answer says.
Are you on the homework or the preparation, Jose?
Handwork.
We're doing the prep. It's based off of the preparation.
No. But look at the example.
I don't have the homework in front of me, so I can't verify that or not. I haven't done that yet. They would do that after the group quiz.
I printed it, so I have here. If P equals 1/10, what is the smallest value of N that satisfies the requirements? And according to the answer, the N is number 100.
Okay.
But I don't know how did they get 100.
What question is that on, Jose?
Homework, question number 6.
Homework paperwork.
So do we have to multiply this times 25?
Quarter.
Okay. So, if we go back to our very simple equation there,
Go do something. Go do
x
something.
divided by n, p hat equals x divided by n, right? P hat equals x divided by n.
Oh, x divided by m. Yeah, yes, it's okay. I remember.
Right.
X
So
divided by-
then it has to be greater than or equal to 10. I think that I thought it was headed somewhere, but I wasn't.
I do that too. It's like, nope, lost it.
Yeah.
Well, right, because the p hat equals x over n just gives us the percentage for the population. It doesn't.
Right. So is x the same as in the homework example 1 and n is the same as 10? Do those equal? You know what I mean? The 1 is our x and the 10 is our n. So then to satisfy the requirement of being greater than 10, n would have to be 100. Because
What?
1 divided by 100 is 10.
What does it have to be greater than 100?
Well, there are two requirements to fulfill for this whole p hat thing. If you look at question number, or if you look at the information up above question number 5.
Yes. N multiplied by p.
Yeah. Use the following
Okay.
information for the next 3 questions. I think those are the requirements that have to be fulfilled.
Yes, I remember.
So if equals x over n, and my thinking is correct, 1 divided by 100 is 10.
Yes.
Yeah.
I got it.
So then 1 over 4 to be greater than or equal to 10. 1 divided by what number?
Yes. Okay, you have, I found a solution.
Oh, good.
Okay, yes, it's okay. If you have here n multiplies by p is greater or equal than 10, okay, we have the value of p, right? The value of p is 1/10.
0.25.
One fourth, sorry, 1/4. So if we solve this equation, the answer is 40.
40, yeah.
Yeah, 40. N is 40.
Yeah, I agree with you, Jose, because we have to just use that information they gave us above question number 5, and one of the requirements, n times p is greater than or equal to 10. P is 0.25 if you do the multiplication, right? And then you just solve that equation.
So you're saying 1 minus 0.25 is 0.75 times n needs to be greater than or equal to 10.
Yeah.
Right, but it's simpler to just go with the other one. N times p is greater than or equal to 10 is a simpler equation. So,
and our p is 1/4. So then what times 1/4 is at least equal to 10?
Right.
And it's 20.
Oh, I get it. Okay, I get it.
Oh, 40.
I get it.
40.
So a quarter of. Okay. Yep. Yeah, that makes sense then.
Right. So then we're just
I wasn't
solving
getting that either.
for n. Yeah.
I mean, I read it and it just didn't make any sense.
Yeah. I think that's correct. If the math is right on that, but I guess it is.
Sounds
I
right.
don't have my regular setup tonight, so I really don't. Here's my calculator. Yeah. Good call, Jose.
Yeah, good job.
So this is what we're doing over x over n.
No, that was off. That was,
Okay.
don't go with that.
So what formula are you going off of?
If you go to question number 5 on the quiz.
What is the quiz?
Up above question number 5, it gives us information. We can use the following information for the next 2 questions. We conclude that p hat is normally distributed if n times p is greater than or equal to 10. So those are the 2 requirements that we have to check for our normal distribution with p hat. And they both have to be satisfied in order to be able to use p hat and all the equations that we'll be working with. So if p equals 1/4, then we just plug that into the n times p is greater than or equal to 10. And then we're just solving for n.
And 40 times 1/4 is a 10.
Yeah.
Dang, you guys are smart.
Well, that was all Jose.
Good job, buddy.
Mm-hmm.
Is everybody got that? Everybody understand that?
Yeah.
Yeah, I think so.
I'm still stuck on it. I don't know why it's not registering.
So, sorry, I don't know your name. Matt? Are you Matt?
My name's Matt, yeah.
Okay. So, Matt, if you take that equation up at above question number 5, n times p is greater than or equal to 10. In question number 7, they tell us then that p equals 1/4.
Okay.
So then we've just got n times 1/4 is greater than or equal to 10. So just, if it's easier, pretend. So now we're just looking to solve for n.
So we just need to make sure 10 is one of the quarters of equals
So,
out
yeah,
to 1/4.
We're just asking what times 1/4 is greater than or equal to 10.
Okay.
Right? Because if you use your algebra and you move things around.
It would basically, Matt, it would be x times 0.25 equals 10. So you divide the 10 by 0.25.
Yeah.
How many quarters are there in 10?
Well, it would be not
There's 40
exactly.
quarters.
10 divided by 0.25 gives you 40. Because
Yes.
it works the other way when you divide with a fraction. Gives you a higher number. So
Okay.
well, that one actually makes a lot of sense now.
Okay.
Thank you, Becky. That helped.
That makes sense, yeah.
Does that help?
Yeah, thank you.
Okay.
Yeah.
Good. Okay. So we're on to 8.
Yes.
So what is the mean of p hat? And we said that was equal to plain old p.
Yep.
So it's 0.4.
Mm-hmm.
That's my guess.
Yes, you have to use the formula. Square root is p multiplied by 1 minus p over n.
That's for number 9.
8. No, that's for number 8.
Right.
That formula, Jose, is for standard deviation.
Oh,
and this
yes.
is asking for mean.
Oh, yes. The answer is p, 0.
Deviation
The answer is 0.4, right?
Mm-hmm.
Yes.
times.
For number 9 is 0.1.
Yeah. So number 9, we use that equation, right, Jose?
Yes, it's correct.
And you already did the math on that and got 0.9?
0.1. 0.1.
0.1?
Yeah.
Yeah, I got 0.1 and then the square root of that, though.
Yes.
We got the square root of 0.1.
0.1.
And it's 0.1.
Yeah, that's the answer I have.
Mm-hmm.
0.1. Okay.
So is that
Does everybody get that?
Is that where you go 1 minus 0.4 and then you get the 0.6 and then times out by 0.4?
Yeah.
Yes.
Yes.
Okay.
Yeah, and you got 0.24 over 24.
24. I'm still working it. I'm a little slow.
It's all right,
You're
Matt.
good.
It's getting a bit harder with trying to remember all the different calculations and everything. And
Yeah.
Mhm.
X's, Y's, and Z's.
yeah,
So, and
D and T and F and
what's your
P
Who's
and
hard?
X bar and
Maybe.
I got it. Yeah. All right.
So now we need to find on 10 p hat. And that is,
Number 9, 10, sorry, 10.
Number 10.
10.
I don't know how to figure 10.
I don't either.
Well, the first, it's going to be P. P is 0.3.
Mhm.
So P hat is the same as P.
Mhm.
So it's 0.3. Number 10 is 0.3.
Okay, yeah, because that's the mean, right?
Right. P is equal to P hat. P hat is equal to P.
I was looking for a formula. That was too easy.
Yeah, it was way too easy.
Standard deviation.
We're getting to the formula.
Okay, so the next one's that p times 1 minus p.
Yeah.
oh, I jumped ahead. Okay, so 0.46, 0.046.
You did that? You did the equation?
Yeah. I jumped ahead and did the
Nice.
Are you on 11?
yeah.
And what did you get?
Let me do it again. Hold on. I just want to make sure I got it right.
Because I have
I got-
0.21 over 100. Square root.
I got 0.0.
Yeah, 0.21 divided by 100, and then the square root of that is 0.046 when we round up. Is that what you got, Jose?
Yeah, yes, that's nice.
Okay. Yeah.
Hey, let's vote for a group test this next time we have an exam. All in favor?
Yeah, no
I'm
kidding.
in.
I.
Wait a minute. In my notes for number 12, it says the z-score is the same as the thing we just did.
No.
No.
Different.
No, the z-score is p hat minus p over the standard deviation.
But
No.
p hat minus p is 0.
Yeah.
Except that's the thing, is that p hat can't be the same as p.
No.
No.
Z-score is x minus m is x minus the mu over the standard deviation is the z-score.
So is x here 100?
Oh, okay. I wrote it down based on what the book said, which was p hat minus p.
Yeah,
So-
they say they're equal.
No.
Well, no, that's the thing, is that, so the p hat, yeah, p hat doesn't equal p.
But up there it says mean of p hat equals p. Previously in our homework, it said that they were equal.
Yeah.
Where I don't remember seeing that in the homework in the book.
But the equation for z-score is x minus mu divided by standard deviation.
And our
No.
x is 100?
Nope.
No,
Our x is going to be, now we go to that equation I was talking about earlier for the p hat. P hat equals x divided by n. So in this
Oh, that's right.
example,
That's right.
x is 35 divided by n, which is 100. We get 0.35.
Oh, sure. Oh, so
I'm confused. Hold on.
okay.
Yeah, me
In
too.
this case,
So if
what-
we're saying p hat in some instances is p and p hat in some instances is the value, how do we know which is which?
Yeah.
Because
Well-
the book, I'm looking at the book, and you've got p hat for the z-score in 3.3.1 worked example. You've got z equals value minus mean over the standard deviation, or
Mhm.
p hat minus p over the standard deviation. So we can't we can't have p hat equals p and p hat minus p. Otherwise, we got 0 over whatever, and then it's 0.
No,
And
uh,
standard deviation is always
our
equal to zero.
answer, our answer to number 10 is wrong. What we have to do is to
That's
find
what I'm thinking.
the p hat. The p hat is number 35 over 100.
Okay, I
So
can
it's
go with that.
0.35.
Yes, 0.35.
How did you get that?
Oh, you have you
Your
can see
hits over the number.
you have the number of hits.
Hits
number
over
Oh,
the number.
35 hits.
Uh-huh.
That's right. Okay, that's what. Yeah,
35.
0.35. Because
Okay.
okay. Where did I wrote that down because I remember that somewhere. I was like, wait, what?
And now we have to recalculate the
Oh, there it
standard
is.
deviation.
No, the standard.
It doesn't change, right?
It shouldn't
Okay,
because
okay.
you're.
So this p hat
Or
is necessary for the z value.
hold on.
Our 11 will change now.
I know it will because it's 0.35 instead of 0.3.
0.3. 0.35 times 0.65 over 100. And then the square root of that.
So 0.48.
0.48.
No.
Hold on. So 0.35 times 1 minus 0.35.
Is 0.65.
Right. I just do the whole thing on my calculator. Then that divided by 100 equals that, and then the square root of that. So 0.048. Is everybody else coming up with that same answer?
I didn't work it.
Honesty's great.
Yeah. I trust your calculating skills.
So then our z is 0.35 minus, no. Our mean is
0.35 minus 0.3
Which is-
over 0.048.
and you put it over 0.48 because that was
That's the standard deviation.
Standard deviation.
So it'd be 0.05 over 0.048.
Where'd you get the mean from?
So the mean is the 0.3.
Ah, yeah.
they gave it to us.
The true mean. The true mean.
Yeah, the true mean.
Mhm.
Thank you, Jose. Yeah, exactly, Jose. The true mean as opposed to the mean of this one, which is 0.35. So 0.35 minus 0.3 over the standard deviation of 0.048. It's starting to click.
Yeah,
Good.
that makes sense, doesn't it? Yeah.
Well, keep talking so it sticks so you can explain it to me later when mine doesn't.
So it'd be 1.042.
1.042. Nice.
Yeah.
That's the z-score
Yeah.
Yes.
because you
Where's my
divided
normal
that out.
probability app?
Yes.
1.042. So probability would be
Z-score.
0.149
Oh, wait a minute.
for the probability. Sorry, number 13. I put the z-score into the normal probability applet.
0.42.
What'd you get?
0.149.
0.149.
0.149?
Yeah, 0.149.
How did you get that? I put the 1.042 in the z-score.
You only do the
No,
right
no.
hand.
The z-score is 1.091.
How'd you get 1.091, Jose?
It seems like no, the z-score, the z-score.
Right. How'd you get the z-score of that? How'd you get that?
I did the calculations.
Right. What was your calculation? I just want to make sure I didn't screw up.
Okay, is 0.35 minus 0.30 divided by the square root of 0.3 multiplied by 0.70 over 100.
No.
No.
It would be the square root of
Mhm.
0.35 times 1 minus 0.35 over 100.
No,
So
no.
we already have the standard deviation. That was in question 11. So
Yes,
you can just get rid of that whole and just put
but remember that we
you can
don't
put
have to.
0.35 minus 0.3 over 0.048.
Are you sure? Because that we let me see. We don't have the standard deviation.
We figured the standard deviation already. That was in
0.
question 11.
Mm-hmm.
Question 11. No, it's because our standard deviation is okay.
What did you get for question 11 on the quiz, Jose?
0.4. No, it's 0.046.
46?
0.046.
Okay.
Because you have to use the true mean, the p.
No, for this one we use the sample.
No. As you can see, the
Right?
the formula says the value. The value is the sample, the p hat, minus the true mean, p. And the standard deviation is calculated using the true mean.
So what is p hat, did we decide?
P hat is
1048.
0.35
So it is 0.35 minus
minus 0.30.
3.
30 is the true mean.
Yeah, but Jose, we're using the formula for z-score. We're getting the
Yes,
z-score.
I am using it.
So the value for the to find z-score is x minus mu divided by standard deviation.
Yeah, but I don't know if you can see if we're using the same formula.
Wait, was it?
I'm
So
using
for your standard deviation, Jose, did you do 0.3 times 1 minus 0.3 over 100 squared?
yes.
And then the square root?
And I got 0.046. Maybe my calculations are wrong.
Did you do
No, that's what I got when I did that. But
Did you do 0.35 minus 0.3?
3.
Yes,
Mm-hmm.
we have 0.05 divided by
it would be 0.046 if we use the 0.3. It's 0.048 if we use the 0.35.
Let's divide 0.05 divided by 0.
Yeah, we used the point.
Did we use the wrong?
Okay. What happens?
Oh,
Look, listen. What happens?
I think you're right, Jose.
In these calculations, I didn't round it.
Oh.
That's why I have a different number.
No,
Okay.
no, Jose, you have a different number because you used the 0.3 in your standard deviation calculation, and I used the 0.35.
No, because if you can, you have to look at the formula. It is the true mean. It doesn't have that hat. Can you? I don't know. I don't know if you see it.
No, Jose, I'm saying I think you're right on this one because what I did was I used the p hat.
Okay, you use the p hat.
I used the 0.35 in the standard deviation calculation as opposed to the true mean of
Why is different?
So, yeah, that would give us a totally different answer.
So you're saying it's 0.3 minus 0.3?
No, 0.3 minus or times 1 minus 0.3 over 100 to get the square root to give us a different standard deviation.
And you think it's 0.3?
No. So to get the z-score, I think we used the wrong standard deviation. So going back to question 11.
Mm-hmm.
So what I did when I did the calculation is I did 0.35 times 1 minus 0.35 over 100, and then the square root of all of that.
Right.
Which gave us a 0.48 when we round up.
Mm-hmm.
But if we did it off of the true mean, which is 0.3, it would be 0.3 times 1 minus 0.3 over 100, and then the square root,
So
which would give us the 0.046 for our standard deviation, which would then change our z-score.
I agree.
Oh, because we did p hat. It's just plain p.
Yeah.
Dang us. Okay.
So
Did you get it, Trina?
Jose, you're on a roll tonight, buddy.
So then that would be
I have a formula.
0.05 divided by
If you want, I will share it.
6.
for
So
you.
1.87. Is that what you got for your z-score, Jose?
Okay, I will share what I have.
No. What'd you get for your z-score?
My z-score here. Can you see it?
No.
I got 1.087 for my z-score.
That's what I get when I recalculate. Jose, I was just wondering what the number was. What was the number?
This my answer was this.
Okay. The problem is your standard deviation.
But I didn't round this. This part I didn't round it. If you round it, it has a different answer. You will have a different answer. You will have something like this.
You've got the bottom wrong
like
there, Jose. It's 0.35 minus 0.30 divided by simply divided by the standard deviation.
Yeah, you don't have to put in that whole calculation, Jose.
But
you just put in the standard deviation that you already figured in question 11.
Okay,
So
but
0.35.
Yes, but we will get a different number. Which number did you get?
No.
So you're saying it's 0.5 over that
0.05 over 0.046.
Okay.
I agree with that.
Yeah.
Yes.
And then we get a z-score of 1.087.
Right, yeah.
And we put that z-score in the bottom, shade the right, and our area up top is 0.031.
Get at least 35. So we shade the left, don't we?
So you have the number is 1.087, right?
Yes.
Yeah.
Yeah.
1.087.
Yeah, for question 12.
I put in 1.87.
1.87, question 12.
Put in the wrong thing. So then we're shading just the left.
Yep.
Just the left?
Right. It's at least.
Or just the right? Because it's more than.
It's more than. Well, it's still going to give us the same answer. Yep.
1.385.
0.1385.
1.39, because we have to round up.
More
Yeah,
than, right?
good catch.
0.139.
Right, so it's just the right hand, Jose.
Yes, it's okay. Yes, is the area, the p-value is, yes, the p-value.
Yeah, the area up at the top.
The area is 0.1385.
Right, but you have to round up to 3 decimal places.
Oh, 9.
Yeah.
So what's the formula for the z-score? Is it not the value minus the mean over the standard deviation?
Yes.
Yes.
That's exactly what it is. So if we were doing it on a traditional thing, it would be the x bar minus mu over standard deviation.
Okay.
So is 11 still
If our value minus
0.04?
what's that, Matt?
Is 11 still 0.048?
No.
0.46.
Mm-hmm.
What is it?
0.046. So it just went down by 0.002.
The formula for the standard deviation then.
Standard deviation is the square root of p times 1 minus p. The 1 minus p is in parentheses over n.
Oh, okay.
So it's your true mean times 1 minus your true mean over your sample size.
Sorry about that is the p hat. P hat equals that formula.
Yes. No. Oh, yeah,
So
that's the
how
standard
that-
deviation for it.
Mm-hmm.
Okay.
Sorry, the mean.
And p hat is the total
Mm-hmm.
mean.
We are in question number 14.
Yeah,
Yes.
standard deviation of p hat. Here's our p minus 1 minus p again, or p times
Right.
0.52. That's going to be a tiny number.
Yeah, right.
0.015.
0.011. That's what I got.
Woo. So I'm taking 0.52
Mm-hmm.
times 0.48 divided by 200,
2,000.
2000.
2,000. That was something I did wrong.
And then we get the square root, which is 0.011.
That's what I got.
Okay.
Mm-hmm.
Okay.
That's what I got.
And for number 14, what is the p hat?
We don't have to know p hat.
Mm-mm.
Why?
We're just finding the standard deviation
The
of p
standard
hat.
deviation. Yes, it's okay. It's okay. It's okay. Sorry.
That's
So
okay.
once you get the 0.52 times 0.48, you get that answer is 0.2496, and then divide it by 2,000.
Right. And then you do the standard, and then you do the square root of it.
Square root of. Okay.
And z-score now is
Would be
minus
0.
0.52. We're going to end up with a negative number on top.
No, because, oh, yeah. Well, it would be a
Mhm.
negative z-score.
Yeah.
Right.
It's
Right.
0.5 over 0.01.
What numbers are you plugging in there for your z-score formula? What's your x?
X would be 0.5 because it's getting less than 50% of the votes.
Okay. And then
And then the mu would be 0.52
okay.
over our z-score of 0.011.
What was
Right.
your first? What was your first number?
0.5,
Why do you get the 0.5?
because that's what they're asking in the question, is we want to determine the probability that the results of the survey will suggest a candidate is losing the election, getting less than 50% of the votes.
Of course, that's what it is, Trina. Okay.
We want to know
Okay.
50% as our mean
Mm-hmm.
minus the mu, which is our true p, which is 0.52, over our standard deviation of 0.011.
And you got negative 1.818.
I don't know. I haven't done it yet.
Oh. Okay.
Negative 1.82 is what I got.
Say it again.
Mm-mm.
Negative 1.82.
You have to round it to 3 places, don't you?
Oh, you're right. Negative 1.818.
Right, and the probability up top is,
To find number 15, we have to use as okay, that we have here the true is the true mean is 0.52, right?
Mm-hmm.
And the p hat is 0.50. To find a z value,
it is 0.5.
sorry,
0.5.
yeah, 0.5, yes.
So it'd be
divided
0.5 minus 0.52 divided by our standard deviation, which is 0.011.
Mhm.
So then in the applet, if I put that 1.818 in, and I
we
need to
want
find
less than, so
Mhm.
it's
Point-
0.035 when we round up.
0.035.
yeah.
Yeah. It's 0.0345, but we round up to 3 places, so yeah.
What question you guys on?
16?
16.
Where are
What's
you
the
at?
answer for 15?
15?
I
Negative
couldn't get 14.
negative 1.818.
And then 16, I typed them in the wrong places. 16 was that number on top, 0.035.
Yeah.
You guys are good. We got 100%.
Sweet.
Good.
the
I
answer
can
is
use it.
the p value is 0.0345, right?
0.035.
Mm-hmm.
Ah, we round it to 3 decimals.
Yes.
Wait, what was the answer to number 4?
4. For the
Or
letter
is
C.
C?
See.
Oh, C. I don't know why I hit B. That was weird,
Because you could.
right?
Why is this so easy when we work together for me, but it's so hard to figure out what I'm looking for and I'm on my own?
I don't
It
know.
does help.
Okay,
It does
number 15 is minus, right? Negative
Yes.
1.818,
Yes.
right? Negative.
Yes.
And number 16 is 0.035. Is it okay?
Yep.
Yep.
Becky, you're welcome to join us whenever.
Thanks. I appreciate it. It's kind of a weird week for me, but this is really helpful. How do you guys, does one person usually post, or how do you guys do that?
Yeah, I'll post it.
Okay. Thank you.
And I'll put your name down.
Thanks.
Thanks, Matt.
Thanks for the help,
All right,
everybody.
guys.
Have a
Thanks.
good night, guys.
Hey, do we need to discuss the project?
Oh, yeah, we need to discuss the project.
Yeah, we
Yeah, we
do.
gotta get that. Got a lot to discuss.
What are you thinking you want to do for the project?
And Becky, I don't know if you'll be involved with us or not, but you're more welcome to stick around if you want. But. I don't know. What do you guys think of anything?
No, not right off.
So is there any, I was trying to think of something fun. I have a whole box of M&Ms here in their packages, real size of M&Ms bags. Is there anything saying that there's a certain amount of colors or numbers in a bag? Or anything like that that we could do, that we could count colors? I think it'd be easiest if we did something like that. Is there anything?
That would be easy. The examples that they gave were Are there 1,000 chips in every bag of Chips Ahoy? Are brand A paper towels stronger than brand B? Price differences on books. Something about people walking on grass. But I don't see why we can't do the
M&Ms.
thing. That would be simple.
Could we do the same number of each color in each bag, or use an ANOVA and see if one color shows up more than another color? Throwing it off the top of my head. You can say no and I won't be offended, but tonight only that I understand.
The saying in this video, we have to know what type it is, because that's one of the reasons why you always.
It's a little bit to eat M&Ms. It's okay.
So we have to know what statistical method we're going to be using.
Mhm.
One of the 8. So what method would that be?
It'd be the ANOVA. Are they all equal, or each of us buy like a bag of M&Ms or something? Are they all equal amounts?
But I think we need more than just one sample, right? Or more than 5?
I would think we need more than 5.
I don't know.
Well, I have 20,
I mean, if we each did
I have 20
a certain
bags.
amount. Well, I don't want to do 20.
I don't care what we do.
That's sure.
I'll eat them all for you. No, just kidding. I don't know what else could we do?
No, I like that. It's simple.
It's a true example.
Yeah, it is. Yeah, sounds good.
Would it work if we each bought one in our own city, made, I don't know, a difference between, well, you're in Peru, right, Jose?
Yes, I have to buy M&Ms here.
So would it be different than if, I don't know, they're all made by Hershey's, that won't work.
It doesn't matter. I adapt to your.
I'm just brainstorming, guys.
Yeah, because we have to divide the project. We can
We have to
collaborate.
what?
We have to divide the project up.
Yeah, we do.
Mhm.
So we have to do presentations, PowerPoint presentations, all the things here. Let me see.
Hey, let's do popcorn.
What?
Popcorn?
If you pop
What
popcorn,
would you want to do?
do they always pop the same amount? Different brands of popcorn.
Yes, it's okay.
We can count the old maids in the bottom of the pan between different brands of popcorn. I'll just brainstorming. You can say no. You're not going to hurt me.
That's good.
Tonight only.
What?
I said tonight only.
Tonight only. You'll hurt my feelings tomorrow, but not tonight.
So with the M&Ms, would that be a quantitative? Well, it'd be quantitative because it's numbers. So would it qualify for 3 or more samples? Do you know that?
That's what I was thinking. Are they all equal, or is one different? You're awful quiet, Kevin.
I'm looking up online trying to find if there's anywhere that actually states for sure what percentages are supposed to be in each bag, because I've seen a couple of websites that say that they found that the percentages are X blue, X green, X brown, orange, red, yellow, blah, blah, blah.
Mhm.
But I can't, I'm on mms.com, and I'm not finding anything that says for sure what percentage of each color is supposed to be in each bag.
I see M&M's color distribution analysis from joshmadison.com.
Right, that's one that I just looked at, and it's 24 blue, 14 brown, 16 green, 20 orange, 13 red, 14 yellow percentages.
Yeah.
But I'm not finding that on M&M's website. I figured, why not, you know?
Yeah,
Why not?
we can contrast those numbers with ours.
I guess we can just go off that and say that that's the mean percentages.
They have the mean, yeah, right? And we have a sample mean, and we contrast if.
Well, based on 100 M&Ms if there's 100 M&Ms in a bag, 24 would be blue, 14 would be brown, 13 green, on and on. Yeah, I guess we could devise have each of us get a bag or two of the, you know, just not the big bags, but, you know, the individual bags, and, you know, do a sample of them. Right? Would that work?
Yes.
I think so.
I think
why
that.
not?
And we're not working with human subjects, so our IRB, our internal review board, would be easier.
Yeah.
Because if you deal with human subjects, you really got to get some paperwork and decide where you're going to save it under lock and key and get them to sign the paper.
Yeah.
So do we need 30 samples to be
Now, did anybody watch the video that he posted today?
Yeah,
in
I
regards
watched some of it.
to the
Part of it,
project
yeah.
design? Because he said that about a third of, he only generally approves about a third of projects on the first try.
And he said the reason why is in the study on number 5 and number 6 and 7 are the 3 that is why he usually sends these back. 6 is saying which statistical method are you going to use in the study. Most people get that wrong. 5 is your response variable, quantitative, or categorical? We should know that.
Okay.
And then the
Yeah.
null hypothesis.
As long as we have have it set up right, I don't see why it'd get rejected.
Because we'll use an ANOVA. We've not talked about chi-scores yet.
Yeah. No, it would have to be an ANOVA because we've got 5 different things.
And he said the F, G, and H, the categorical, is which one is the chi. Those are all surveys. So we wouldn't have to do a survey with ours. So
Yeah, we wouldn't be doing that, yeah.
So an ANOVA quantitative, where nulls are their equal, our alternative is one is different, at least one is different than the rest.
Right.
And then see number 11, where we don't involve human subjects, takes out a lot of work for us.
Oh, yeah.
All right. Okay. Where are you guys finding that? I'm not.
It's under design the study.
Is that in the contents of the project, final project? Okay. Design the study instructions or design the study?
Yes, instruction. I think
Instructions.
it's instructions.
Okay.
Should I stop this broadcast?
Yes, please.